Here we go. Good afternoon, everyone. Good morning. My name is Bobby Wager. I am a mechanical engineer with GSA's central office. And today's training is the 2024 P100 training for Chapter 5, the mechanical engineering section of P100. I'm joined by my colleague, Mark Cucci. He's also a mechanical engineer in central office in the Center for Engineering. And we're going to get right into it. So we're just going to provide an overview of all of the substantive changes to Chapter 5 of the 2024 P100. And as we go along, please capture your questions and answers in the designated Q&A for Google Meet, and we will address them as we go along. So first, lagging a little bit. First update we have is to the performance sections of Chapter 5. So if you're familiar, the beginning of Chapter 5 has all the performance tables. This first section for humidity control, section 5.1.2, there's an update to the M&V requirements for humidification control. It is now required to provide M&V for baseline and all tiers of control. The next section is a pretty substantial update, cooling and heating robustness. So if you're familiar with the last P100, there were pretty specific requirements for the arrangement of, say, chillers or boilers to satisfy heating and cooling criteria for facilities. Instead of requiring a minimum number of equipment, we're now trying to embody that performance-based approach and change the requirements so that now the baseline requirement is if you have a set of equipment that is installed, so say you have 3 chillers installed and you lose one of them, the building's temperature set point does not go more than 5 degrees of Fahrenheit above what that set point is. So say your summer temperature is 75 degrees, you lose a machine, the building does not exceed 80 degrees Fahrenheit and also does not exceed a relative humidity of more than 60%. So you're still left with partial redundancy of the existing equipment that is there, but you may see a rise in your temperature set point. That is the new baseline criteria for equipment arrangement, whether it be for chillers or boilers. And then we added a tier 1 requirement for this performance, which is a more conventional N+1 requirement. Whereas if you were to say you had 3 machines, you're operating 2 of them, you lose one, it's okay. You have another one right there on standby. It picks up that load without any issues. So I'm not sure if I'm spazzing out here or if something's going on.
No, a hand's being raised, but it was just blinking.
I'm sorry, I'm not seeing it.
No, go ahead, Leon. Leon Hawkins has a question, I think. Unless that was by mistake.
All right, I'm going to finish my point here, and then we can go ahead. So calculations are going to be required to be submitted that capture this, so that if you had, say, designing to the baseline criteria, you would demonstrate if you lost the machine based on the sizing criteria that you followed for your design, you're not exceeding those metrics of 5 degrees Fahrenheit or 60% relative humidity. And if you're opting to pursue tier 1, that's a little bit easier because you'll show, hey, I have 2 machines that are designed to, capture the peak demand of the building. I have 1 machine on standby. It's an N+1 criteria. So that would be what we look to see. So that was my final point on that slide. If anyone had a question, I'll be happy to answer it now.
Yeah, go ahead, Leon. I think you had a question, unless that was a mistake raised by hand.
No, that was a mistake.
Okay. Bobby, Greg, go ahead.
Yeah, Bobby, is that when you have different sized chillers in your plant, do you just default to the largest chiller?
So
how would that work?
Greg, I'm going to get ahead of that real quick. You shouldn't have different sized chillers in your plant. P100 still requires you to have equally sized machines. So the thinking is your machines are equally sized, and that if you were to lose one, your other 2 equally sized machines would be picking up this load. So we're not deviating from, equally sized or mismatched sized or pony chillers or any of that nature. We're still holding that requirement of equally sized machines.
All right, that's pretty clear then. Thank you.
Bobby, we have a question in the Q&A. Can we hit that one also?
Yeah, Greg, I agree. It is more of what is funded based or tier one, anything can be designed, correct? Yeah. So we had a lot of feedback just to, I don't want to digress on this point too much, but we had a lot of feedback regarding questions on redundancy. And that's what kind of motivated the change here, was to ensure that those concerns were being addressed, because people felt that they couldn't design to N+1 because the P100, had a requirement that said all 3 chillers need to be equally sized for the peak demand load. So you were never going to get an N+1 design per that, P100. So we offered a tier up of design that was a bit more robust, that offered that N+1. And then the baseline kind of falls back to that partial redundancy approach.
And Bobby, back to that slide just for a second. I think I realized what I wanted, but I was a little bit confused about the slide. The X on this slide does not mean that there's not three pieces of equipment. The X is meaning to indicate that one of the pieces of equipment failed.
Yeah, it made sense in my head. So apologies if that didn't translate easily.
Yeah, I just wanted to clarify that because I was concerned that people were.
It is representative of a failed machine. I did my best with what Google Slides offered me in terms of graphics. Moving right along. So filtration, we updated this section to require MERV egg filter classifications. If you're not familiar with what that is, it's a label that is applied to a MERV filter based on the testing requirements that were applied. So X-ray 52.2. Puts through a set of requirements, which essentially is the filter won't lose its MERV number rating if I'm sorry, I'm hearing myself echo. Sorry, guys. If it's starting to get loaded, whereas non-MERV A filter classifications, they could, once they start getting loaded, they immediately start losing efficiency and start going down. So a MERV 13 filter may not actually be a MERV 13 filter after being used for a little bit. Another update is under the tier 1 performance standard, we added a standard for wildlife and urban interface areas requiring filter racks and fan performance that can accommodate MERV 15 bag filters for any sort of wildfire smoke and whatnot. And there are some references here that we'll share with you following this training. And the last performance section update is HVAC operational efficiency. We revised the requirement to comply with the more stringent versions of ASHRAE standard 90.1 minimum efficiencies, and provided clarification on the FEMP minimum efficiency requirements and what's required to be complied with in 90.1 and FEMP. This has been a question that has come up a lot, or a comment that we've seen on many projects that are installing new equipment like this. So we just want to offer more guidance with that in P100. So updated the section accordingly. Moving along, section 5.2, added a requirement to comply with ASHRAE standard 188, Legionella risk management for building water systems. So treating biological growth in the hydronic systems of the building. Section 5.3.2, expanding on GSA's electrification requirements. This is a big update for P100. There's a new section under Chapter 1 that speaks to the electrification requirements. As you may recall from the 2021 Addendum 2022 version of P100, all new equipment, all new HVAC and domestic hot water heating equipment is to be electric. This gives more of a criteria of, depending on your funding streams and, the nature of the replacement, what is required. This was extensively covered in the sustainability P100 training, but if there's, any questions, whatnot, following that reference back, we'll be happy to address them. But Chapter 5 is now making a reference to this. And for Chapter 5, Section 5.3.2.1, which is the chiller plant section, it refers back to that performance criteria that I just spoke about along cooling robustness. So just making sure the sections are coordinated. We also removed a section of domestic construction material requirements when waiving Buy America and requirements per the FAR 25.2. Section 3.2.5326, roof mounted equipment. Air source heat pumps, condensing units, and condensers are now listed as equipment that are permitted to be installed on the roof. Makes it a lot easier to accommodate air source equipment now. And we also added a reference back to Chapter 3 for roofing and horizontal waterproofing membrane systems, just to coordinate those two sections. Big updates to the controls sections. I'm not going to dive too deep into each one of these because it was extensive, but if you're keyed into all things, BMS, building controls, automation systems, please, review this and familiarize yourself with these changes. There's, clarified language on use of lawn talk protocols. There's added requirements to coordinate with your regional building smart teams and, your smart building point of contacts for, coordination of digital systems. It's just an effort to try to maintain consistency in our building control systems, which we felt was kind of falling short in terms of requirements and also guidance for those that weren't ultimately familiar with who to talk to. Just continued updates for the respective sections that require it on those requirements. Also, very intentional references to the Building Technologies Technical Reference Guide. This is a big update coming out of the all things building automation system. So if you're not already familiar with that document, I suggest you familiarize yourself, as it speaks to a lot of BMS requirements that the P100 is going to make reference to, but doesn't otherwise, explicitly reference, partially for brevity purposes, but also just to, stay within its own lane. Also, some updates to integrated sequence of operations regarding labeling and marking of CO2 sensors in your control systems. And occupancy counting, there was updates to this as well in terms of integration with other GSA interfaces on smart building side. And once again, additional references to GSA IT and smart building system requirements regarding scanning and remediating of any IP addressable device. We saw a question pop up. Will the recent change to Niagara BMS be reflected in the P100? Joe, answer to that is the Niagara framework update, which some of you may have seen come through. I believe it was announced last week. Niagara framework is thoroughly addressed in the building. Oops, I went too far. In this Building Technologies Technical Reference Guide that I referenced. So P100 already makes reference to this guide. And if you have any further questions regarding the Niagara framework interface, please reach out to your respective smart building points of contact in your region, who often communicate or should be communicating with their central office counterparts to offer that guidance. And just additional clarification on connectivity to GSA's networks and IP addressable devices. A lot of really good updates here that, once again, you should be making reference to. These are new sections to Chapter 5 that specifically speak to these things. So please, make sure that if you're, unsure of any of this guidance or need more clarification, that you're familiarizing yourself from it. Got another question from Greg. When a new building is funded from Congress, is there anything put out that states what tier level it's funded for? We always get it to say Tier 2 architectural building, but base mechanical, for example, but it always after the fact and stated as that is all the project can afford. That costs more money it's taken out. So, Greg, I think I understand your question here. I'm going to say it depends on what your end users are requiring, what the program of requirements for that facility is going to ultimately require. We know we have some end users that are adamant about redundancy, for example. So they're going to want to see N+1 there. So automatically you're going to be clicking up to a Tier 1 for your, mechanical infrastructure. And then as it goes to, terminal devices and whatnot, that level of design requirement or what, in infrastructure requirement is going to be something that, will have to be, understood before that, scope of work is written and that design is starting to get, awarded and flushed out. So that's what I would say to that in terms of, where the mechanical falls in line with that. Lance, you have something to add?
Yeah, I'll just chime in, Greg. We also have the performance matrix that all the project managers should be using when you're setting up your project. Right now, we're in the process of updating that performance matrix, and hopefully by the end of this fiscal year, we'll have it updated for the new 2024. But then you can use that to actually go through all of the requirements as you're setting up that project and determine which ones either you or your client want to be at what levels. And that way, when it gets funded by Congress, you know exactly what's getting funded. And then you can use that same document to hit the street with, to advertise for design services, so that your design teams know what they're designing to with all those tiers as well. So it's a very useful document to sort of keep track of the tiers throughout the whole process of the project. So make sure you check that out.
Thank you, Lance. Yeah, that's a perfect explanation. So with that, I'm now going to hand it over to Mark to pick up the rest of the updates.
Hey, good morning and good afternoon to everyone on the call. Thanks for joining us. So the cooling and heating coil section, new text was added to this section for coil protection from fossil fuel combustion products. So what was added for urban environments and combined urban marine environments, aluminum fins with electro coatings are preferable to just copper fins. So this is to take care of the nitrogen oxide and sulfur oxide that are present from fossil fuel combustions. And also, once you get the slides, we'll post those either a day or two after the presentation. This slide includes a link to the whole building design guide corrosion toolbox, which has lots of other information on corrosion. I think was there a question or someone raised their hand?
Yeah, Mark, you have a question that says, what about urban coastal environments? This specifically is speaking to urban and marine environments, which I would assume also qualifies coastal.
Yes. Yeah, marine / coastal. Yeah, absolutely. Okay, the copper pipe fitting section of the chapter, a new text was added referencing the refrigeration system safety standards. So ASHRAE 15, standard 15 safety standard refrigeration systems, and ASHRAE standard 34. Can you please, yeah, thank you for muting. And ASHRAE standard 34 designation and safety classification of refrigerants. Those are the two standards that define the refrigeration ventilation that must be provided to rooms. The point here is that refrigerant, if it leaks into the room, is heavier than air. So it fills up a room like water fills up a bathtub. And if the refrigerant isn't allowed to leak out to another room, then it could go above a person in the room's head level and suffocate someone. So ASHRAE has had these standard refrigeration ventilation requirements for quite some time. What's changed is the standard has been updated, and I'll get to that in the next few slides. But this was added just to P100 to make sure that these safety calculations are included in your design calculations and in the narratives, and actually shown on the drawings where these transfer openings need to be located. And also at the bottom of this slide, we included a link to the HVAC system refrigerant safety calculations, some further information that I'll show on the next couple slides. Let's see, explosive refrigerants, that is in those safety standards. It is the 2AL refrigerants. You have to look more deeply. These ventilation calculations are not that I have here on the screen are not specific to the explosive or flammability calculations. Those are different than these calculations, but they are included in the safety standard. So anyways, I'm not going to go through each one of these, but these are there's 11 items that you need to make sure your project includes when you get these calculations from your mechanical engineer. But I just wanted to include these on the slides so you have easy reference to them. And as I pointed out before, what has changed, ASHRAE Standard 15, 2019 and earlier, they had requirements to calculate the size of room for refrigerant leak. But unfortunately, what was not clear and was not prescriptive was the size of the opening that you needed in a room to ventilate the refrigerant leak and the location of the opening. So without that information, an engineer needed to do a detailed modeling or a study to figure out, to determine if the refrigerant can transfer quickly enough from one room to another to avoid suffocating someone in that room. The good thing is the ASHRAE standard 15/2022 has changed, and they have very prescriptive natural ventilation opening sizes and location requirements. For example, the transfer opening in a room to allow the refrigerant to transfer from one room so it doesn't get too high above a person's head. That transfer opening can be no longer higher than 12 inches above the floor. So a long way of saying, if your engineer is using ASHRAE standard 15/2022 and providing all the calculations, showing where the ventilation openings are needed, showing on the drawings the sizes of those openings, the free area, then you should be good to go. If your design is older and that information is missing, you might want to reach out to your mechanical engineer to make sure it was designed correctly. Okay, copper pipe fitting section, new text was added to this section. Refrigerant piping must be installed in accessible locations, such as corridors, machine rooms, and this is probably the most important part, be located at a ceiling height that would make the piping accessible for repair and replacement. So I think the big point of this first bullet point is, especially with VRF, variable refrigerant volume systems, which only have an expected life of 15 years, the refrigerant piping that is snaked throughout the building, if it leaks, will have to be repaired, and in 15 to 20 years will most likely have to be replaced. When the indoor and outdoor units from a VRF system are replaced, the refrigerant piping will have to be replaced. So the point is, make sure the piping is located so it can be easily replaced without having to really disrupt the building. The other item added was that cooling coil condensate piping must be type L copper, and just added a couple photos here. Copper's on the left and PVC is on the right. So PVC should not be installed for condensate piping. Okay, a new section was added for air source heat pump condenser discharge. So the two images on the right are images of a domestic hot water heat pump unit, but where practical and cost effective, cold air discharge from an air source heat pump condenser operating in heating mode must be recovered and diverted into adjacent electrical rooms, mechanical rooms, IT rooms, closets, via ductwork and or louvers for supplemental cooling service. So this will mostly apply, especially with our new focus on electrification, to building hot water heaters. So with electrification, all hot water heaters, in the past may have been gas-fired, fossil fuel hot water heaters. They will now have to be heat pumps or electric hot water heaters. So if they're heat pumps, which most likely they will be, because heat pumps will be more efficient than electric hot water heaters. And if they're heat pumps and they're located inside the building, the room that the heat pump is located in will get cold because the hot water heat pump will discharge cold air. So what we'd like the engineer to do is take a look at the amount of cold air that heat pump will discharge and find a way to use it if possible. A large building, especially a large new courtroom, a large new office building with large amounts of large capacity hot water heat pumps, will have a substantial cooling effect. So that could be used for electrical room, IT closets, etc. Last point, though, it's important that the supplemental source of cooling must not be the only means of cooling. So these rooms will still have to be provided with cooling from the typical HVAC unit, but we'd like to be able to use this, what could be called as waste cooling, to save some energy as possible. A new section was added for duct construction. All conventional supply, return, exhaust, air ductwork must be fabricated from galvanized sheet metal unless otherwise indicated. So pretty straightforward there. A new section was added for flexible duct connections. So flexible duct connections must be limited to a maximum of 5 feet of distribution and are only permitted to make final connections between the terminal branch ductwork and the air outlet. So as the picture shows, the flexible ductwork should just be from that branch takeoff to the diffuser for final placement. And the use of the flexible ductwork is not permitted above hard ceilings where they're very difficult to get to. During testing and balancing, a lot of times if the diffuser is not getting the airflow, it's because that flexible ductwork may have popped off. So the point here is if that's above a hard ceiling, it would be very difficult or impossible to repair or make sure that ductwork is connected without cutting into the ceiling. So in that case, in hard ceiling, we'd like to, it should be provided with hard ductwork. See, any new questions? I'm just checking. No,
Yeah, Mark.
we're good.
No new questions.
Okay, the plumbing section, there was a section deleted in the plumbing section that was discussing fossil fuels and supplemental electric heat, et cetera. But as Bobby pointed out in the previous mechanical slides, that reference was deleted. And the section now just refers to the electrification section, section 1935. And as Bobby pointed out, section 1935, that requires for domestic water heating, heat pumps, and or electric water heaters. And again, just images of typical electric water, heat pump electric water heaters. Lance, go ahead.
Yeah. And I just want to remind people with the building performance standard that we have now, that's a federal requirement. We now also have to do laundry, which we don't do too much of in our buildings, and cooking equipment. So those are 2 other items that were added to the electrification list, just for everyone's awareness.
Gary, go ahead.
Yes, just for clarification, does this electrification section still allow for gas for backup or supplemental heating if required still?
It does in certain locations. If you're in one of the cold ASHRAE climate zones, but you have to show the life cycle costing aspects of it, and you also have to show that the amount of fossil fuel being used by the building is less than the ESA requirement that sets how much fossil fuel can be burned in a building now.
Thank you.
Yeah, what Lance was referring to, and I just checked it the other day. It's 10 CFR 433, and the entire section now is updated with, I think it's section B, Bravo, with the fossil fuel reduction requirements. So each climate zone and each building type has a limit of amount of fossil fuel that you could use. We did see in one of the recent projects, and a courthouse renovation project, they are electrifying the building using heat pumps. But Gary, as you're pointing out, they're using fossil fuel just for backup. And the calculation showed that the backup met these new fossil fuel reduction requirements. So it looks like in cases, at least in that example, if you have a heat pump and the fossil fuels backup, that may be able to meet the new requirements. Charles, go ahead.
Yeah, just to complement what I was saying, here at NCR, we are doing electrification projects using electric boiler as a backup when needed. Over.
Yeah, that's great. Yeah, heat pumps with electric backup. That's I think the key is, as Lance pointed out, is the life cycle cost analysis of the different options and alternatives is really important to look at to see which one is most cost effective. David, go ahead.
Yeah, not to go down a rabbit hole, but then you got to put your boiler on the generator and it triples your generator sizes because you can't have the. So up in north, you're probably just something to think of. You got to remember that besides the fact that the electric boiler has a COP of 1, which is terrible compared to the heat pumps, they also need to be on the generator, and the generator needs to be sized for your full heat load at that point. So, and we're one of those courthouses, Mark, and that was the whole discussion between the two options.
All right, if no more questions, then we'll move on. Okay, in the plumbing section, there was a section added about keeping water flowing in buildings to prevent Legionella. So modifications to point of use water outlets used for human consumption or washing purposes must include post-installation flushing and testing procedures that comply with the most current version of the PBS drinking water policy and desk guide. So again, at the bottom of the slide, I provided a link. We provided a link to that desk guide. You might want to take a look at that desk guide to make sure what should be included in your project specification related to these flushing and testing requirements. In addition to that, dead legs are prohibited in potable water plumbing to lessen the risk of Legionella proliferation. And unrelated, janitor closets must be provided with domestic hot water and cold water. Here, a section to the plumbing piping was probably more of a clarification. Sanitary, waste, vent, and storm piping, any project scope related to piping up to 5 feet outside the building should be referred to Chapter 4 Site Utilities, covered under the Site Utility section, not the P100 mechanical section. Under the plumbing piping, there's a couple items added to these sections. Domestic water piping, solid copper supply lines must be installed from the fixture shutoff valve to the fixture connection. Here, a lot of, not a lot, probably most plumbing fixtures you see now have either factory or field installed flexible supply lines and or flexible lines from the internal parts of the fixture to the shutoff valves. All of those are not permitted. The point here is that they could more easily leak, cause a leak to the building. So all plumbing fixtures should have hard pipe connections. Even plumbing fixtures with factory provided flexible water connectors are not permitted. I think we had a waiver about this about a year ago or something like that. I think this prompted this change to the P100. Here, plumbing piping, this was added to the section, domestic water piping, again, for Legionella prevention, provide a recirculation loop on all cold water risers and major branch distribution ends for flushing purposes. So this is something you want to make sure you take a look at when you're reviewing the plumbing riser diagrams to make sure you have this recirculation loop. A new section was added regarding isolation valves. So isolation valves must be provided for all lateral piping entering all bathrooms, mechanical rooms, kitchens, and other rooms provided with domestic water where there is at least one fixture. The valves must be an area that can be reached without the use of a ladder and are easily accessible in the case of emergency. Again, the point for these valves is to be able to easily shut off the water if there's a leak, so that the room doesn't get flooded or destroyed. Go ahead, Scott.
You said more than one or one fixture, but is it more than one or just one fixture?
Where there is at least more than one fixture. So
two fixtures in a room, then we need a isolation valve.
Yes.
Got it. Thanks.
So yeah, and the locations, like I said, is important. Without use of a ladder, it can be easily accessed. There should be a printed sign that shows the location of the shutoff valve, and this is more of a maintenance item, but valves must be exercised regularly. And then for detention areas and courtrooms, the isolation valve must not be in the prisoner holding cell, and probably should be included, probably not in the prisoner area, detention area at all. It should be outside of those areas. A new section was added for hose bibs. So hose bibs must be provided along all exterior facades at ground level and at rooftop level at a minimum increment of 100 feet on center. The hose bib locations and distance to be determined based on design and input from the regional GSA facility management team. So work with the O&M team with your designer to figure out the best location for these hose bibs. Hose bibs must also be provided in mechanical rooms and parking structures, and ensure that the hose bibs are easily accessible and able to be isolated for future repair or replacement without having to perform an entire shutdown. So I think that last bullet point, Bobby, maybe you can help me with this one. I think that's saying you need to probably have an isolation valve somewhere upstream of the hose bib.
Sorry, it took me a second to call you. Yep, that is correct. So the assumption is whatever piping, wherever the water that is feeding that hose bib is being sourced from, there is, on the lateral takeoff, an isolation valve. So if you ever had to close it, you can, and that you're not at the mercy of the system potentially being, drained down through that hose bib if it fails.
Great, thank you. Okay, new question. Hose bibs at minimum 100 feet. Is there a maximum?
I think that's what's being implied there.
Yeah, I think it's maximum 100 feet on center is what you don't want to go more than 100 feet without a hose bib, Lance.
It should also be perimeter, not, because it's vague. You don't know if it's every 100 square feet, or I think it's inferred. I would infer that means perimeter.
Let's see, was there another question? Are hose required to be on non-dead end runs as well?
That was meant to be hose bib. Sorry, Mark.
Okay. Can you explain that one? I'm not completely understanding that one.
Well, I mean, it's connected to the domestic water system, but I know like lavatories, things like that, it's very well implied that those aren't to be on dead end runs. I was just wondering if hose bibs fall under that same category, because you don't supposed to drink from a hose. It's not a requirement.
I'm not, I think I'd have to get back with you, Bobby. Can you answer that one?
Yeah, Greg, I'm not sure I'm following either.
So like a drinking fountain or anything like that is considered potable water. It says that they have to be on a loop. They can't be dead end run for flushing purposes. My question is, do you consider a hose bib to also not be, or is that not considered drinking because it's a hose?
I mean, essentially, if it's sourced from the same potable water system, yeah, I guess it's considered a dead end. But the difference is you can open that line and flush it if need be. So I wouldn't really qualify it as a dead end. A dead end is essentially literally just a cap pipe at the end of a riser run that doesn't go anywhere, and it's not allowing for or encouraging circulation of water. If for whatever reason, if your hose bibs are not connected to a potable source of water, the concern is obviously much less, because it's the potable water system that we're concerned about in terms of maintaining regular circulation. Josh has another question mark. How is the bathroom entering isolation valve supposed to work? Most piping comes in overhead and drops down at the unit where we already have the fixture. So Josh, this is for if you have, obviously multiple fixtures. You have a branch pipe coming in off of a riser. right at that branch section, there's an isolation valve. So if you're ever to isolate the whole bathroom, you have a means of doing so, and you're not just isolating locally at one or two fixtures. If there's a bigger issue upstream or there's a larger issue downstream and you're just trying to intercept it, you have means of appropriately isolating that. What Mark's point was is if you do, as you incorporate those, you have to maintain access to them, because more often than not, bathrooms have like hard ceilings and whatnot. So an access door is going to be required.
And yeah, just adding to Bobby's explanation, which I agree with, Josh. Yeah, I think this requirement is going to add more piping. So as you said, it typically comes overhead. It's going to have to loop down, drop down to an accessible location before it feeds the individual fixture. So it's probably going to require a few more feet of piping in most situations to get to a accessible, in the wall, a valve box, so you can reach this shut isolation valve.
There's another question from Opie that said, how about backflow prevention requirements? I'm not sure there were updates to backflow prevention that you spoke to, Mark.
Yeah. There's no updates in this update to backflow preventers. So I don't know if you're suggesting that we need to add something, but hopefully that answers your question, or you can jump in if you need more information. Okay, moving along. Floor drains. This section was revised slightly just to also require floor drains in kitchenettes and lactation rooms. And then let's see, I saw one other question.
No, Opie, no backflow requirements for our hose bibs. Obviously, there's vacuum breaks and conventional code required installations are required at hose bibs, all hose bib locations, especially those exposed to the exterior of the building. But yeah, no backflow prevention specifically mentioned there.
Okay, a new section was added, overflow pans. Overflow pans are required to be furnished under all domestic hot water heaters. And the pans are required to be equipped with water sensing controllers that will shut off the units and send an alarm to the BAS system, or produce an audible alarm if the BAS system is not compatible with the alarm. So this is simply an overflow pan with a water sensing device. Again, that water sensing device, if it senses water in that pan, needs to shut off the water, and alert the BAS so that maintenance O&M can take care of the issue. Let's see, I think there was a question.
No, Gary, there is no language regarding freeze protection hydrants on roofs. At least not under Chapter 5. If it's specific to standpipe systems, I would defer to the fire life safety sections of P100.
Yeah, I was referring to a hose, like a counterpart to a hose bib for the roof.
Yeah, so if you have a hose bib terminating at the roof, it's considered penetrating the building envelope. Appropriate vacuum break and whatnot would be required, just in any other conventional hose bib design.
And then let's see, John had a question. Let's see, P100 valves, and I mean, P100 typically doesn't go to that level. All valves and all those are included in the specifications. Do you agree with that, Bobby?
I agree. We're not in the business of, very much narrowing a design down. We want, an engineer that we hire to recommend that. That is to say, if a building has an existing standard, say for a specific valve type or whatnot, we are to maintain consistency with that, but the P100, won't dive into that level of detail. Jim had a question, no use of instant tankless hot water heaters. They're certainly encouraged, Jim, just in the event you were not using an instant tankless hot water heater. and you were using a hot water storage like the one pictured here, water sensing or leak detection is overflow and leak detection is required.
And I'll add, the instant tankless, we're not discouraging them, but again, when you do the analysis, especially if it's a new building, the heat pump versus the instant should be looked at, for energy use, efficiency, and life cycle cost.
We have a question regarding drainage and lactation rooms. For lactation rooms, are drains required in rooms that there are no sinks or plumbing, as this is an optional amenity? I believe the language specifically speaks to where plumbing is provided. So if you have water going to that room, you need a floor drain. If there is no water going to that room, there is no purpose for a floor drain. Regarding floor drains, I assume waterless trap primers are referring to trap seals, correct? That is my understanding, Jared. Yeah, and that is also what's pictured here, which is convenient. OP says, is it to shut down the gas for heating of the water or mechanical valve from the domestic water? OP, I believe you're talking about the leak detection. It could be both. It's more just to alert someone, an operator of the building, hey, you have a leak at this location, at this equipment, go check it out. And if there is sequencing language coordinated with that to trigger a shutdown, certainly that would happen.
Okay, let's back to the slides. There was a reference in the piping section that was referencing fuel, gas, and fuel oil piping, but it was just deleted. It wasn't needed. The gas and fuel oil piping is clearly identified in the P100 section. That hasn't changed. The reference was just deleted. Okay, this was the accessible for maintenance section. There was a requirement added that condensing units for split systems should not be located indoors. So it says outside the building envelope, but that means don't, as this picture shows, don't locate condensing units inside the building. I've seen them inside garages. I've seen them inside of basements. So put them outside the building where they belong, not inside the building. The alterations to existing building section, there was a section added for right sizing equipment. So direct replacement in kind of equipment that is aged out is prohibited. Any new equipment installation must be specifically sized for the current programmatic needs of the spaces served. So basically says right size the equipment. You never know if that 20, 30-year-old piece of equipment is oversized or undersized. So make sure your project scope of work includes new heating and cooling calculations so that you can properly size the new equipment. Any questions? I know we have a lot, so we'll open up the forum to any questions that people might want to cover.
Scott Slaughter has a question. The P100 references the submittal matrix and lists required calculations, etc. The matrix is based on 2021 P100. Is it still applicable, and when will the additional mechanical calculations be added to the submittal matrix?
Is Lance still on the call? We're discussing the P100 submittal matrix. Intent is to update it by the end of the fiscal year, and the new calculations for refrigerant that I went over, and the new P100 Appendix A6 life cycle cost analysis requirements intend to add some of those requirements to the submittal matrix.
Thumbs up from Lance. Good job, Mark. Is it okay to place outdoor units in ceiling plenums? I'm going to say no.
Yeah.
Ceiling plenum is considered inside the building envelope. An outdoor unit should only be located outdoors.
this I need to add a point on this one. The reason I'm asking this is some buildings, they are multi-floor building where they add these split units, and there is no way to just reject outside to the outside. How do we?
I mean, that's a challenge that building is going to have to handle itself, but certainly deviating from P100 to manage that is not acceptable, and there's probably not a solid chance that a waiver would even be approved for that. But if there is an option to connect to, say, louvers for intake and discharge air service located appropriately along the building facade, and you're just putting that condenser above the ceiling and it's fully ducted, then yeah, certainly I would say that that's an acceptable solution, so long as that heat of rejection is not being discharged into the ceiling plenum directly. But that's obviously a design challenge that's unique to specific, applications. Jason has a question, says, back to fittings. Does P100 allow pressure push fittings on domestic water heating, water, black iron gas pipe? Jason, I suggest you familiarize yourself with Chapter 5. There is guidance on press fittings for specific services and up to specific pipe sizes. That is all captured under Section 5.3 of the P100. Jared says, was there any discussion of adding epoxy line cast iron piping for federal parking garages in colder climates? I don't recall if a proposal for this was submitted, but we do see from time to time waivers that speak to this, and it's either epoxy line cast iron or PVC is being proposed, but there's no current guidance in the P100 that explicitly speaks to that. It's because it's, I guess, a rare occurrence. It is handled on a case-by-case basis. Greg said, say they make ducted condensers. Thanks, Greg. Ductless split systems are great for this. Okay, let's be very clear, though. When we talk about ductless split, you're still not locating a ductless condenser above a ceiling plenum. So let's just be very clear there. Thanks for a great session. Can you talk a little about wildfire smoke migration and what it means for building occupancy? So, Ann, I touched upon this earlier in the presentation regarding our updated requirements for wildfire risk management and how we now have a requirement for air handling equipment that interfaces or handles outdoor air to provision for an extra filter section so that carbon filtration can be slotted in. That is not just something that you're blindly retrofitting equipment with. The equipment obviously has to be appropriately arranged to accommodate that, and the fans obviously have to have enough oomph or static to overcome that. But that is what that guidance is working to address. Therefore, our facilities can operate safely without entraining smoke.
And also, I'll add when we moved to MERV 13 filters, that was the standard filter for smoke migration. So that took care of the smoke requirements just by going to the MERV 13. So it took care of those. But as Bobby pointed out, we added the carbon filter sections where a carbon filter could be added if needed.
Thanks, Mark. Yeah, and again, this carbon filtration is more to stop smoke, like the odor of smoke from entraining the building. Scott has a question. With the filter requirements, can you even use a ductless mini split? So, Scott, the filtration performance section speaks to different filter requirements for different types of systems. So whether it's a DOAS system, decoupled ventilation air handling unit, or a fan coil unit, there's different filter criteria for that. If you're using a ductless mini split system for whatever reason for supplemental cooling, the thinking is it's probably not handling air that people are going to be breathing, and that you're handling your ventilation component from a separate system. But if you have a ductless mini split being used to supplement occupied spaces, then yeah, you have to comply with the filtration requirements, and in that case, it would be considered like a fan coil unit of some sort. So those filter requirements would be required. Good, Mark.
Yeah, I'll just add, Scott, that has come up in a couple of current or recent VRF designs. And I think what we want to point people towards is if you're using the VRF, then you probably have to move towards the ducted VRF, the concealed unit, where it's, as Bobby pointed out, it looks more and acts like a fan coil unit versus the cassette type. I think we did find one manufacturer that made a cassette with the MERV 13 filters, but typically the cassette and wall mounted don't have the MERV 13 filter. So I'd really push people towards the concealed ducted VRF type of system so you get the proper filtration.
As I'm reading through the latest version of the P100, pleated MERV filter or MERV 13 filters for 100% recirculation air terminal units, such as fan coil units, both DX and hydronic. To me, that would include even server rooms that we just are recirculating air in there to require MERV 13 filtration. So if it's not actually required, maybe we need to adjust that language or provide some exceptions.
Yeah. Again, I treat it as what's considered an occupied space. A server room, while a person's going to go in there, is not normally occupied. And I believe, don't exactly quote me on this, I'm just from my experience, I believe that room classification is, also defined as that in ASHRAE 62.1. But yeah, certainly for even smaller, like direct drive fan coil units, MERV 13 pleated filters are required if it's handling air that people are, going to be breathing as part of the normal occupancy. And, we feel that there's enough pleated MERV 13 filters on the market that can accommodate a variety of fan coil unit installations. Michael has a question that says, is it necessary to install a floor drain in an existing kitchenette break room that is being renovated that doesn't have a floor drain? So I would, treat this if there's existing plumbing that's already there and, the floor drain wasn't there and you're just refreshing the finishes. You're not pulling the trigger on that, requirement. This is for, new installations in which you're, there's a kitchen or kitchenette didn't exist or a break room didn't exist and you're putting a new one in. That said, okay, Mark.
I also will add, take a look at, I don't know the section off the top of my head, but in section 1 general in the P100, the renovation alteration section, it talks about that. In a lot of cases, you need to include in your scope of work the P100 or the requirement if you want to update this floor drain. So meaning if you want to put in the floor drain, you might make sure your scope includes a floor drain and your budget includes a floor drain. So
yep, thank you.
Take a look at that. That'll help you there.
Gary says, if a ceiling space mounted condensing unit is ducted to a ventilation relief air shaft, would that be acceptable? A lot of conversation about these ceiling mounted condensers. I would say, again, you should be directly interfacing with outside for a condenser. We're often stuck with retrofit, path of least resistance retrofit options that seem like a good idea at first. And then, 20 years later, people are left with that mistake that was made. So I would, again, push to say, if it's an outdoor condensing unit, it is located exclusively outdoors. If you have a ducted condenser, you are ducting directly to the outdoors and not via another means through there. So to answer your question, Gary, I would encourage that you duct through that ventilation relief shaft until you get directly to the outside. Joe asks, in the future, the expectation is that operations will not need to close down the outside air during a wildlife fire event, correct? Joe, I'm not going to speak to how a specific facility is managed. Obviously, more mission critical facilities that must maintain continuity of operations, you cannot starve the space of outside air for the occupants inside. So they will need to, but if you're evacuating a building, I would certainly assume that the damper's closed because the air handlers are going to be turned off. Jebby has a question. What do you think about the capacity by adding a carbon MERV 15 on the unit with MERV 13? Jebby, that is what the filtration section speaks to, and that if you're going to design a system that is to handle a MERV 15, carbon filter, that the the air handling unit's fan performance must assume that in its design so that it's not going to negatively impact the fan's performance. I was trying to emphasize that point before, that you're not just retrofitting existing units with this without doing that level of due diligence. Ron says, I'd like to ask, are folks meaning condensing units or air handling units? AHUs can be mounted in the ceiling, correct? Yeah, we're just ensuring that we're speaking two different things. Outdoor condensers, which are often associated with split systems, meaning you have an evaporator and a condenser. Outdoor condensers, such as the ones pictured here, are to be located outside. Air handling units that are just sourcing ventilation air from the outdoors most certainly can be located above a ceiling plenum, because the ductwork that is getting that outside air is sourcing it from direct, from outside. The point of that comment was that we're not locating condensers that are intended to be outside above a ceiling plenum and rejecting heat to the ceiling plenum and not to the outdoors.
Yeah, and as Greg rightly pointed out, a condensing unit that's designed to be ducted can be located inside. I think the issue is that a lot of engineers who make the mistake, they, as shown in the photo here, they just put a these condensing units cannot be ducted. They're not aware of other manufacturers who make ducted type units when they're forced with a situation of, where they can't locate the unit outdoors. So they use the right piece of equipment, it should be fine, but this is the wrong application.
And the obvious reason is, we shouldn't be adding loads to spaces that weren't designed to accommodate them. Even if you have a mechanical space that has, exhaust fans that can, introduce an air change, if it's meant to be outside, it should be outside.
So does that apply if we have a louvered outdoor air intake or the mechanical rooms on the perimeter? And
yeah, I would still say, Gary, if it's located inside the building envelope, it needs to be ducted to the outdoors, and it can't be passively injecting heat to a room that is then carrying, being picked up by another system. Because the argument can be made, what if that fan's not running? And now you have, or what if that fan fails? Now you're overheating a space because that supplemental system is still operating. I feel like this is something that can easily be avoided. So we should be applying our due diligence to make sure that doesn't happen.
Right. If you're located in an exterior mechanical room, you can duct it to the outside.
Certainly.
Yeah, even in garages, what I've seen, I've seen a lot in garages, but the typical discharge on the top of the condensing unit, hits the ceiling. That's maybe even at 8 or 10 feet, but then it just recirculates back into the intake. So
I have created plenums for the top of discharges on splits in garages through wall, but you have to be very careful there that you're not creating a lot of static.
Right.
There's a warranty issue with the unit.
Exactly. You got it.
So we have some time left. We have a couple more questions. Is there any concern? Sorry, Mark, go ahead.
No, I just said keep the questions coming.
Keep them going.
We have time.
Is there any concern that the MERV 13 will reduce energy efficiency of units and may cause issues with the system pressure? Or are we just expected to be putting these in new units? Sorry if this was already said and missed. If you're specifying a new piece of equipment to comply with the filter requirements of the P100, the assumption is you're designing that equipment to accommodate a MERV 13 filter. So you're selecting the appropriate filter type that is not going to give you an energy penalty on those units. A common misconception is that the higher you go in MERV, the more friction loss you're incurring, and therefore the more energy you're consuming. That is not always the case. Depending on what type of filter you are specifying, and if it's appropriate for that equipment, you won't see a negative performance criteria. More often than not, these assumptions of loaded media are comparable to lower MERV ratings if the filter is selected appropriately. If you're retrofitting, and I know this wasn't part of the question, but if you're retrofitting an existing piece of equipment with upgraded filtration, that due diligence of understanding whether that fan system can handle it is obviously critical and should be performed before installing new filters. Susan asks, it's unfortunate that Liebert Vertiv advertises indoor condensing units, mini-mates, 1 to 3 tons. It leads people to believe it's okay practice. Susan, I certainly agree with you. There is definitely, though, the last time I specified a Liebert unit was some time ago, but Liebert does make what's called piggyback units. and they are indoor rated units with ducted connections. So the condenser is actually inside, but you are doing the same thing in that you're ducting to the outside. So you're rejecting the heat directly outdoors, and you're not just recirculating it within the building. Hope that's clear.
And I know it's not a condensing unit, but the one example I showed, this heat pump water heater, it's hard to tell here, but the fan and the intake are on the sides of the unit, and this unit is intended to be ducted, discharge air ducted outside of the building. So.
Adam, you have a question?
Yeah, go ahead, Adam.
You're muted.
I'm sorry, I was mute. Yeah, thank you for taking my question. Question is, if you have several fan coil units in the building and you have a condenser on the roof, are we required to have a two-way valve or three-way valve if the condenser has a VFD?
If you're specifying a system that is ganging up multiple evaporators to a single condenser, typically those systems have their own specific components that come with it to isolate one over the other, so that that condenser can obviously continue to operate if all fan coil units are not on at once. But that's a very specific, application criteria that we would follow, and not one that I think it requires broad guidance. But obviously, I would, take that up with the person, designing that system and the manufacturer that they're specifying to ensure those required ancillary components are provided.
Yeah, in this case, we did have a two-way valve. The problem is now the condenser is tripping up, is turned off when all the units reach their set point. So that's the question is like, should we have installed three-way valve instead of two? And that was the reason I asked this question.
Gotcha. Jebby has a question, says, is there any reason not to include a complete section in the appendix, such as 5.1.2 instead of 5.1, typical for all? Jebby, I'm not sure I understand this question. 5.1.2 is a subset of the mechanical performance section, and so are the other subsections of that. Go ahead.
Yeah, hi, Bobby. On the appendix, as I was looking at the change and update, based on that, we all, is always being emphasized 5.1 instead of the complete for quick reference.
Oh, you're talking about the summary of changes?
Yeah, that's why I said
Yeah, we felt highlighting. I understand what you're saying.
Yeah, because all of the other one, you guys can go there and refer.
It's a good point. Yeah, and if we provide a small update, we'll be sure to address that. Thank you.
You're welcome.
Any other questions with the time we have left?
All right. Well, thanks everyone for joining. If there's no more questions, then we'll give you about 15 minutes or 16 minutes back, and have a great day. Thank you for joining.
And please, if you haven't done so already, please download the copy of the 2020